The objective of this lesson is to measure volume using non-standard units of measure and observe the relationship between the size of a container and the number of iterations needed to fill a larger container to capacity. These observations can be generalized to any size of container. Let's look at some vocabulary. Non-standard measurements are measurements taken with anything other than standard units, which are cups, inches, meters, etc. Iteration is the action of repeating a sequence to get closer to the desired results. Volume is another attribute that can be measured. Volume is how much space something takes up. Volume is often described in terms of containers. For example, a spoonful of sugar, a mug of cocoa, a can of soda, a carton of milk, a box of cereal, glass of water, etc. Let's find the volume of this container in units of these smaller containers. First, we are going to determine how many jam jars of water it takes to fill the container. If it can't be filled with a whole number of jam jars, we will say plus some for now. We will use this chart to record and compare our findings. First, draw a picture of the drinking glass, which is the container we are measuring. Next, draw a picture of the jam jar we are using to measure. Use tally marks to record how many jam jars of liquid will fill the glass. 1, 2, 3, 4. Wow! So the volume of this glass is equal to 4 jam jars. Let's see. This play tea party cup is smaller than the jam jar. Notice how the cup fits in the jam jar with room to spare? How many times will it take to fill the glass with this tea party cup, which is a smaller container? We'll record the container by drawing it on the chart. 1, 2, 3, 4, 5, 6, plus some. So the same glass is equal to 6 plus some tea party cups. It took more of the smaller tea party cup to fill the glass and fewer of the bigger jam jar to fill the glass. The tea party cup doesn't hold as much water, so it takes more iterations to fill the glass. The jam jar held more, so it took less iterations to fill the glass. There is an inverse or opposite relationship between the size of the cup and the number of iterations needed to fill the container. Let's see if this holds true with a different size of container. Do you think we need more or less iterations with the larger plastic cup? 1, and some more, but not a full other cup. It takes 1 plus some iterations to fill the glass. It is a larger container, so it takes less iterations to fill the glass. Look at the chart to compare the containers and the iterations. We can see that the larger the measuring container, the fewer iterations, and the smaller the container, the more iterations. An idea of how you can help your child estimate the volume of a container is: show your child a container and a small marble. Tell him or her to estimate how many small marbles it would take to fill the container. Count the marbles as they put it into the container. When they cover just the bottom of the container, ask if your child wants to change the estimate or if he or she still feels comfortable with it. Finish filling the container and see how close the estimate was. Now show your child a large marble or another sized item and have him or her estimate how many of those items it would take to fill the same container. Ask if there will be more or less of the large marbles than it was for the small marbles. If the item is larger, it should take less iterations to fill the container. If it's a smaller item, there will need to be more iterations to fill the container. The objective of this lesson was to measure volume using non-standard units of measure and observe the relationship between the size of a container and the number of iterations needed to fill a larger container. These observations were generalized to different sizes of containers.